Hello, welcome back to Stochastic Processes class, and today we'll be continuing the classification of states. So today we'll be checking periodicity and aperiodicity. So consider this transition diagram. So we have state 0, state 1, and state 2. So from state 0 to state 1, we have 1. From state 1 to state 2, we have the probability transitions to be 1. And from state 2 to state 0, we have the transition probability to be 1 also. So if you consider this Markov chain, you see that there is a periodic pattern in this chain. That is, starting from this state 0, we only return back to state 0 at 3 times. That is, after 3 times. That is, if you start from 0, in the first round you move to 1, you move to 2, then at the third stage you move back to 0. And the probability of moving from 0 to 0 over 3 steps will still be equals to 0. Do you understand now? It's equals to 0. Over 6 steps is still equals to 0. That is 1, 2, 3, 4, 5, 6 is still go back to 0. Over 9 steps again, it's still equals to 0. And over 12 states, ... So in other words, the probability of moving from 0 to 0 over n steps will be 3, 6, 9, 12. So if I start from 1 at every 3 times, at n equals to 3, you will be returning back to the same state. The probability from 1 to 1 over 3 steps is equals to 1. Over 6 steps is equals to 1. Over 2 steps is equals to 2. So we call this short state as a short state with a periodic pattern is called a periodic state. A periodic state. Okay, and then this state has a period with period written as d of 0 equals to 3, while d of 1 also equals to 3. That is, at every 3 steps we'll be returning back to 1, and also d of 2 also equals to 3. At every 3 steps we'll return back to state 2. At every 3 steps we return back to state 1. At every 3 steps we return back to state 0. So take note of that illustration. So we can now write that the probability, not the period of state, the period of state I is the largest integer d. This integer d satisfying the following property. Which is probability from I to I over n step is equals to 1 whenever n is not divisible and then by d. Okay, so you can now write that the period of I is shown by di, and then the probability, if we have probability of I to I from state I to state I over n step is equals to 0 for all n greater than 0, then we let the period I will equals to infinity. So also you need to take note that if your period I, your di, is greater than 1, then we say that the state I is periodic. And then if your di is equals to 1, then we say that state I is aperiodic. So take note of that two concepts. Aperiodic. So and also you can know that all states in the same communicating class have the same period. Then a class says to be periodic if states are also periodic. Then that is if I communicate with J that is in the same class, then di is also equals to the J. And the importance of this our periodicity is that it plays important role when we are discussing about the limiting distribution. And it's also turned out that in a typical problem whereby we are given an irreducible question, we need to check if it is aperiodic or not. Alright, so then here we stop for this periodics. So in our next video we try to check the continuous time Markov chain, whereby we'll be moving to another type of stochastics process in this video. Thank you for watching. So hope to see you in the next video.